Guys, just give you guys a heads up. We are still doing our last day of solving by factoring. And instead of going right into the next section, which will be a little bit different, we're actually going to take a break from the factoring for a few days, which maybe you guys are looking forward to. I don't know. I could factor every day. I love it. But before we go on to the next topic, the next section, I want to quiz you while this is fresh in your head. So tomorrow I'm going to give you a 10-question quiz on Delta Math on solving equations by factoring. All right, so I'm going to do a couple with you today to show you something a little bit different, and then I'll let you guys start working and review. Okay? All right. Can I get a thumbs up that you guys hear me and can see the presentation okay? Can you see the notes that I'm about to do? Yes? Okay, sweet. All right, here we go. So guys, you are going to be asked to solve equations by factoring, right? So normally I've been asking you guys to solve quadratic degree 2 equations by factoring. But they're not the only equations that we're ever going to see. When we get to chapter 5, we're going to see higher degree equations. So whenever we can use factoring to our advantage and help us solve other types of equations, we want to be able to do that. So I want to show you right now how you can even solve some degree 3 equations by factoring as well, okay? So just to review with you guys, if you're going to solve an equation by factoring, the first thing you want to do is get everything on one side set equal to 0. Then you want to factor it. And you remember, you want to look for a GCF first, especially in today's problems. Then you're going to set each factor equal to 0 and solve for x, right? We're going to use that zero product property. If pieces multiply to equal 0, somebody's got to be 0. So we'll set our factors equal to 0 and we'll solve. And then guys, don't forget, the degree of the equation tells you how many answers you should be getting to the equation. So a degree 2 equation has 2 answers. A degree 1 equation has 1 answer. A degree 3 equation should have 3 answers. All right, so guys, let's look at the problems. I asked you to solve the following equations, and I put a little star because I just called them equations. I didn't call them quadratic equations by factoring. All right, so if you look at this equation, the first thing you should notice is that this is not a quadratic equation. This is a degree 3 equation. The highest exponent on a variable is 3. So this is a degree 3, which technically I have not taught you how to factor yet. You only know how to factor degree 2s, quadratics, all right? But like any other equation, we want to get everything on one side set equal to 0 first. Then we'll start trying to figure out how we're going to break it down. So I'm just going to move everything to the left side of the equal sign. So I'm going to minus my 11x squareds from the other other x squareds. I'm going to minus my 4x's to the third, and I'll minus them from the other x's to the third on this side. And then I'm going to add my 4x's over. All right, so cancel, cancel, cancel. Now it will equal 0. So what's left on the left? Well, 5x to the third take away 4x to the third is 1x to the third. 6 take away 11 leaves me with negative 5x squareds. And then negative 40 plus 4 gets me negative 36x's. So now you should really notice that, yeah, this is a degree 3 equation. This is not a quadratic. So we can't just go right to our parentheses and start making everything do its job, because that's not how we factor degree 3s. So my advice to you is, if it's a higher degree than a quadratic, then you should definitely be looking for some kind of greatest common factor. All right, what does an x to the third, a 5x squared, and a 36x have in common? They don't have a number in common, but they all have an x. So we're going to factor one of those x's that they all have in common out. And then what expression is it going to leave us with? Well, x times what gets me back to x to the third? X squared. X times what gets me back to negative 5x squared? Negative 5x. And then x times what gets me back to negative 36x's? Negative 36. So now we look a little bit more normal. Now the expression you are left with looks like a quadratic that we normally would have factored. So we're going to do that. We're going to bring our GCF down and we're going to try to factor again. So now that it's a quadratic, we're back to normal. I know whatever I put in the first 2 spots has to multiply to x squared. Somebody's not muted. It's distracting me. I'm sorry. As much as it feels so good to hear sound, it's a little distracting. All right, whatever I put in the first two spots has to multiply to x squared, so we always use x and x for that. And then I know whatever numbers I put here and here has to multiply to negative 36, and my rainbows have to add up to the negative 5x's in the middle. Well, again, you guys know how to factor, so you should know what I'm doing. That's going to take a negative 9 and a positive 4. If I use a negative 9 and a positive 4, everything will do its job. Okay, so now by factoring this, by breaking it up into pieces that multiply, look at what the problem says. It says that this times this has to equal 0. The only way that these three pieces could multiply to equal 0 is if one of them was 0. But it could have been any one of them. So now we set each factor equal to 0 and we solve for our three answers to this degree 3 equation. So take your first factor, x. What if he had to be our 0? So set it equal to 0 and solve. Well, guys, lucky for us, it doesn't leave us with anything to solve. It's just an answer. X equals 0 is one of your answers. All right, well, what if it was the next factor that had to be 0? What's it going to take in order for x minus 9 to equal a 0? X would have to be, add 9, and x would have to be 9. So 9 is your second answer to this degree 3 equation. And then what if it was the last factor that had to be 0? What's it going to take in order for an x plus 4 to equal 0? What would x have to be? Minus 4, x would have to be negative 4. And those are your 1, 2, 3 answers to a degree 3 equation. So we're still factoring. We're still setting equations equal to 0 and solving. We're just getting 3 answers instead of 2. All right, and this will help us in the future when we get to chapter 5. We're going to work with degree 3 equations. So this will help us, already know how to solve them. Is everybody okay? Yes? All right, let's go to one more and let's try it one more time. Let's say I asked you to solve this equation by factoring. You're going to solve any equation by factoring, no matter what the degree is. We need everything on one side set equal to 0. So let's move the 10x's to the left. And then I will minus them from the other x's that are already on that side. All right, we are left with negative 7x to the third, a positive 30x squared, and then 2 x's, take away 10 x's, leave me with negative 8 x's, and it equals 0. Everybody good? All right, well, again, now our job is to solve this degree 3 equation by factoring. If I'm going to factor a degree 3, there better be a GCF, because technically we really don't know how to factor degree 3s. It's quadratics that we know how to factor. All right, so what does a 7x to the third, a 30x squared, and an 8x have in common? They definitely have an x in common. And since it led with a negative, I'm going to pull the negative out with it to make my factoring that much easier. All right, now guys, on your homework, some of the problems are going to have a variable and a number in common. Just take out whatever number they have in common and the variable. All right, what expression will be left if I take out negative x? Well, negative x times what gets me back to negative 7x to the third? Negative 7x squared. Negative x times what gets me back to positive 30x squared? That would be negative 30x. And then negative x times what gets me back to a negative 8x? That would be positive 8. All right. Oh, guys, somebody call me out on that. It would be positive 7x squared. Sorry. If I took out a negative x. That's the whole point in doing it. How can I make that look? I got it. Hold on. Sorry to be annoying, but it still looks like a negative sign. Boom. All right. All right, so now we have a quadratic. A quadratic expression is left, and that's what we know how to factor. So let's bring our GCF down, and let's try to factor it again. All right, I know whatever I put in the first two spots has to multiply to 7x squared. Well, lucky for us, there's only 2 whole numbers in the world that multiply to 7, 7 and 1. So I need a 7x and a 1x to make that happen. I know whatever numbers I put here and here have to multiply to 8. And I know my rainbows have to add up to negative 30 x's. So I'm going to play with 4 and 2. If I put a 4 there and a 2 there, 2x and 28x could get me negative 30 x's. What signs am I going to need to multiply to this positive and then add up to that negative 30x? I'm going to minus and minus. All right, and those are my factors. And again, you should know how I'm getting them. All right, and now look what you're saying. By factoring this, you're saying that this times this times this has to equal 0. The only way this could multiply to equal 0 is if somebody was 0, but it could be any one of these factors who end up being 0. So we set them all equal to 0 and we solve. So take your first factor, negative x, set it equal to 0, and solve for x. I'm going to divide that negative sign away, and I get x equals 0 as one of my answers. And you should be seeing that when your GCF has a variable in it, when you set it equal to 0, you should get 0 as one of your answers. All right? Well, what if this factor had to be 0? What's it going to take in order for 7x minus 2 to equal 0? What does x need to be? Well, add 2, 7x equals 2, and divide by 7. And x will equal positive 2/7. That's my second answer to this degree 3 equation. And then last, what's it going to take if this factor has to be 0? What does x have to be in order for x minus 4 to equal 0? Add 4, and x has to be 4. And that is your third answer to this degree 3 equation. Okay? All right, can I get a thumbs up if you guys feel okay with this solving by factoring? Like I said, as long as you can factor, all you gotta do is set your factors equal to 0 and solve now, and we're just taking it one extra step. Okay, so you are going to have a quiz on solving equations by factoring. Only one of them will be a degree 3. All the other ones on the quiz will be a degree 2, a quadratic, okay? All right, so I'm going to let you guys start working on your Delta Math. I made a Delta Math today. I think it's number 11. We're like going crazy in section 4.3. It's 8 questions, but guys, I had to make it due tonight because if the quiz is tomorrow, then there's no point in making the homework due tomorrow. I need the homework done before the quiz. So you have till tonight at 11:45 to do these 8 questions, and then tomorrow will be your 10-question quiz solved by factoring on Delta Math, all right? All right, if anybody is confused or wants any help, please feel free to stay on the meet right now. Otherwise, you're going to be free to go and you can start working on your Delta Math problems, okay? Have a wonderful day and let me know if you guys need anything.